So we're going to go ahead and look at question 1, and what this is asking us is to graph each set of equations on the graph below it. So on the left side of the screen, they want us to graph negative 8x minus 2y is equal to 8 and 12x minus 3y is equal to 12 on the same graph. So we're going to start with those two equations. Now when it's in standard form like this, I like to go ahead and do this by solving for the x and y intercepts. So first I plug in 0 for x and 0 for y. So if you plug in 0 for x, you're just that negative 8 times 0 minus 2y is equal to 8. So it's almost like just covering up this first part, dividing both sides by that negative 2, and your y value here is equal to negative 4. I'm going to go through and do the same thing, but only now let y equal 0. So it's negative 8x minus 2 times 0. And again, that just is 0. So negative 8x is equal to 8, so x is equal to negative 1. So those are the 2 points that I want to go ahead and graph for that first equation. I'm going to do the same thing over in the next one, but let's graph the first equation. So I'm going to come over, click my line. My first point was 0, negative 4. And then my second point was negative 1, 0. And that's what it means by those x and y intercepts. All right, the first one's done. Let's go ahead and now graph the second one. I'm going to do it the same way. Again, I want to do that table of values for x and y. First plug in x is 0 and then plug in y is 0. So if this first portion, x is 0, I would just be left with negative 3y is equal to 12. Divide both sides by negative 3. And y is equal to negative 4. Let's do the same thing again, only now my y is 0, so that means this portion is going away, and that also is a negative 12x is equal to 12. Divide both sides by negative 12, and again, x is equal to negative 1. Now, this is interesting because those are the exact same points. So what that means is when I graph this, I'm going to draw my line again. And I have those same 2 points. So I'm going to put another point right there and another point right there. And it's a little tough to get those points right on top of each other, but you want to get them close as possible. And what you see here is this is exactly the same line. Now, when two lines are graphed on top of each other, that means you have an infinite number of solutions. So let's go ahead and look at the second equation. I'm going to do this one the second way, but you can do both of them either way. It's completely your choice. These I want to solve for y and graph them using y-intercepts. So I'm going to first move that 2x over to the other side. I do that subtracting by 2x from both sides. That would leave me with 6y is equal to negative 2x plus 6. And then I divide everything through by 6. And this equation leaves me with y is equal to, this is negative 2 over 6, so I'm going to reduce that and make that 1/3 x plus 1. So this is in my slope, negative 1/3, and my y-intercept form, that is 1. I'm going to do the same thing for the next side, and I really want to show you what happens with this because it's a little strange. I move that 1x over from both sides, and then I'm left with 3y is equal to negative x. Divide by 3, and this one leaves me with y is equal to negative 1/3 x. But there's nothing over here. So think about that as being a 0. So what that means here is my slope is still the same. It's going to be negative 1/3, but my y-intercept, because nothing was over there, the y-intercept is 0. So let's go ahead and graph both of those. So for equation 1, I select my line tool. My y-intercept was 1. My slope was negative 1/3, which means I go down 1 and then over 3. 1, 2. That's my first line. Now I click my second line, and again my slope is negative 1/3, but my y-intercept with this one starts at 0. So I start this one at 0, and then I go down 1 and still over 3 as I did the last one. Now, these two on this graph are parallel. What that tells me is that there is no solution to this. Now, question 2 is looking at where these two lines meet, line 1 and line 2. I'm going to make this graph a little bit larger so you can zoom in and you can see right there is where those two graphs intersect. Wherever two graphs intersect, that's the solution. Now this scale is -2 and it jumps to 4, so that means the halfway point in between those would be 3, and that would be a -3, and then you would come up to make that point 4. Now to put this in as a solution, you have to put it in, and they give you a little reminder here, enter as a point. So that means you have to put parentheses, then the -3, 4, and end your parentheses. If you don't put it in that way, you will get the question incorrect. And the last way they're going to ask you is this one, again, what is the solution of this systems of equations? But here you see these parentheses, comma, and then the other parenthesis. What that means is inside here you don't have to put the ordered pair. They're just asking you in the first box you put the x value, and in the second box you put the y value. And again, I'm going to zoom in on that point just to make sure. So my x value is -4. I don't have any up or down movement, so my y value is 0. So that's how I'm going to go ahead and put those into here.